Hello students, as we discussed about atoms in the previous chapter, so it was found that a very important properties like many physical and chemical properties are related to the size of an atom. So it is must to study the size of atom, as if the atom is assumed to be a spherical, then the atomic size is given by the radius of the sphere and it is called as atomic radius. So what is atomic radius? The radius of the atom is called as atomic radius. How we define the atomic radius? The term atomic radius means distance from the center of the nucleus to the outermost shell of electron. That means the spherical atom, if we consider in this way, that is, nucleus is present at the center and electrons are revolving around a particular orbit. So, if there is an electron in the outermost orbit, so at the time when we measure the distance from the center of the nucleus to the outermost shell of electron, then that distance is taken as a atomic radius. What is atomic radius? That is the distance from the center of the nucleus to the outermost shell of electron. That means it have number of shells. In that case, you have to measure the distance from the center to the outermost shell. If there are two shells like this, in that case what we need to do? In that case we have to measure, and if there is a single electron here, in that case you have to measure the distance from the center to the electron in the outermost shell. So what is atomic radius? Atomic radius is the distance from the center to the outermost shell of electron. That means electron should be there in that shell. Then only you have to measure the distance from the center to that shell. So that is about the definition of atomic radius. So how we represent a size of an atom? By its atomic radius. The finding of atomic radius is quite difficult in compared to the measuring of the radius of the ball. What is the reason? Since it is difficult to determine the exact radius of an atom because of the following reasons. There are some reasons. Let us find out what are the reasons. Number one, the size of an atom is very small. That you have know that the atom is extremely smaller in size. Approximately 1.2 angstrom. That is equal to 1.2 into 10 raised to power minus 10 meter. 10 raised to power minus 10 meter. That means it is extremely small value. So because of this reason, it is quite difficult to find out the atomic radius. The second reason, atoms does not have well-defined boundary. That means in order to measure the distance from the center to the outermost shell, it is difficult because in the case of atom, as we have learned the structure, it is in this way, atom. So that means we have learned that electrons are in the different orbitals. So we can say there is no well-defined boundary in order to measure the distance from the center to that boundary. So because of the structure which we have discussed in the previous video, the probability picture of the electrons an atom does not have well-defined boundary, and the probability of finding the electron is never zero even at a large distance from the nucleus. So we can say that because there is no well-defined boundary, so it is quite difficult to determine the atomic radius. So, in order to solve this problem, the approximate radii of the atom can be determined by measuring the distance between the centers of two neighboring atoms in a molecule. So, in compared to the size of atom, the size of molecule will be bigger. So, instead of finding out the radius of an atom, the internuclear distance between the two atoms in a molecule is taken. This distance is called as atomic radius. That means from this internuclear distance, when we make half of it, it gives rise to the atomic radius for that atom. So, if we talk about the hydrogen atom, which is taken in the figure here, two hydrogen atom, and this is a molecule, that is a hydrogen molecule. In that case, we can know that the two hydrogen atom are bonded by a bond that is a covalent bond. Why it is a covalent bond? Because hydrogen atom have a single electron. So in order to get stable, they share with each other. So when it share with each other, that type of bond is called as covalent bond. So there is a formation of covalent bond between the two hydrogen atom. So when we find out the internuclear distance between the two atoms in a hydrogen molecule, which is bonded by a covalent bond, and when we make a half of it, that will give rise to the radius. So since we are finding out the internuclear distance in a covalent molecule, therefore that radius represent covalent radius. So in the covalent radius, we will be finding out the internuclear distance. Internuclear means this is the nucleus of this atom, this is the nucleus of this atom. So distance between the two nucleus, that is called as internuclear distance. This is called as internuclear distance. So from finding out the internuclear distance, we will make the half of this internuclear distance, that will give rise to the covalent radius. So we can do this with the formula, that is R covalent, that is covalent radius is equal to internuclear distance between the two atoms divided by two bonded atom, because here two atoms are bonded, so we'll be doing divide by 2. So in the case of hydrogen atom, experimentally determined value, that is the internuclear distance, is 774 pm, and the two atoms are there bonded, so we will write the values like this: internuclear distance between divided by 2 atom, that is 74 divided by 2. That is, we are making the half of it. The internuclear distance, we have made half. When you solve this one, you will get the value, that is 37 pm. So 37 pm is the covalent radius for the case of hydrogen atom. How we define the covalent radius? Covalent radius may be defined as 1/2 of the distance between the centers of nuclei of two similar atoms bonded by a single covalent bond. Let us once again read this definition. Covalent radius may be defined as 1/2. That is important. You are making half of the distance between the centers of nuclei. That means you are measuring the distance between the two centers of the two atoms, and that is also important, similar atoms. You are taking similar atom here. This is hydrogen, this one is hydrogen. Two similar atoms are which is bonded by a single covalent bond. When there is a single covalent bond between the two similar atoms, then the internuclear distance, that is the distance between the centers of two similar atoms, distance between the centers of nuclei of two similar atoms, that is bonded by a single covalent bond. So when we make a half of this, give rise to the R. What is R here? R covalent. That is a covalent radius. Let us take another example. Chlorine molecule. In the case of chlorine molecule, here also two similar atom is taken, and internuclear distance between two chlorine atom is 198 pm. That is a covalent diameter. This much value is called as covalent diameter. And when you make a half of this one, that will give rise to covalent radius. Since in the chlorine atom, you have learnt in the previous class that there are total 7 valence electrons. From this, in order to get stable, the 7th electron get share between the two chlorine atoms that result in the formation of chlorine molecule. Therefore, a covalent bond is formed due to the sharing of electron. So we can say that the molecule is covalent, and the bond is actually covalent bond here. So the internuclear distance is called as covalent diameter here, and when you make the half of that value, that is 198 divided by 2, give rise to 99 pm. So that is a covalent radius for the case of chlorine atom. So this is about the covalent radius. Next we will discuss metallic radius. In the case of metals, being solid, the atoms are tightly packed. You can see the atoms are nearly touching to each other. This is the case of sodium metal. The atoms of sodium metals are, we can say that they are nearly touching to each other. So, in order to find out the atomic radius in the case of metals, we will find out the internuclear distance between the two adjacent atoms. That is important, two adjacent atoms. So, let us, I am making the two adjacent sodium metal atom here. So, from measuring the internuclear distance between the two adjacent atoms, and when we make the half of that value, that gives rise to the metallic radius, because half of the diameter, you know that is equal to the radius. So this gives rise to the metallic radius. So let us define the metallic radius. Metallic radius, it is the half of the distance between the nuclei of two atoms in a crystalline structure. And that is also important. These two atoms should be adjacent to each other. Why? Because if we take the distance from the center of this atom and the center of this atom, that distance will never give the value of a radius of that atom. So it is important you have to select the atoms which are closer to each other, that is adjacent atom. So internuclear distance of adjacent atom is taken, and the half of that value give rise to what? Atomic radius. So it is the half of the distance between the nuclei of two adjacent atoms in a crystal lattice. This is called as crystal lattice. So here we have taken the two atoms of sodium, and from the center we make the distance, that is called as this is the distance between the nuclei of two metallic atoms, and the half of that value give rise to the metallic radius. Let us take the case of copper atom. In the case of copper atom, this is one copper atom, this is one copper atom. The internuclear distance between the two copper atom, we can say this is the center, this is the center, and the distance between these, when we measure the distance between these, that is the internuclear distance, it was found to be 256 pm. 256 pm, that is for the case of copper atom. So when we make the half of this, that give rise to what? That give rise to the value 128 pm. So 128 pm is the metallic radius of copper atom. Next one is the ionic radius. Before explaining about ionic radius, let me explain what are ions. Let us take the sodium atom. In the case of sodium atom, when you write down the electronic configuration in this way, so you can find out there is only a single electron in the outermost shell. So in order to complete the octet, the sodium, it gives one electron, it loses one electron and form sodium ion, that is Na+. So sodium ion, that is a cation, positively charged ion is called as cation, and these cations are formed due to the loss of electron, that is cation. The next one we have ion, that is anion. What is an anion? Let us take an example of that is chlorine. Chlorine, when you write down the electronic configuration, that is 287. Electronic configuration 287. There is 7 electron in the outermost shell. So in order to complete the octet, it requires 1 electron. So it easily gain 1 electron and form chloride ion, Cl-. That is a negatively charged ion which is called as anions. So cations are formed due to the loss of electron and anions are formed by the gain of electron. So let us define the cation and anion. Positively charged ions formed when an atom of a metal loses one or more electron. Next one, anions. Negatively charged ions formed when non-metallic atoms gain one or more electrons. That is called as anion. And it is observed that cations are smaller than the corresponding atom and anions are larger than the corresponding atom. These 2 points will be going to discuss in the next video. So let us take the case of 2 ions, that is cation and anion. So in an ionic compound, being a positive charged cation and negative charged ion together makes the compound NaCl. So that is an ionic compound. So in the case of ionic compound, when we compare the size of the cation and anion, they are different. So in this you can find out the size of anion, and when you compare the size of cation, they are different, and you can find it out that the anions are bigger in size than the cation. So in such a case, if you find out the internuclear distance between these two, and when you make the half of it, that will not give the half value, does not give the exact radius of that atom, because it is not equal in size. When you compare, these two are not equal in size. So when you make the half of that distance, it will not going to give the exact radius of that ion. So in that case, how we define, we'll take an estimated values. So we'll define the ionic radius in this way. Ionic radius may be defined as the effective distance from the nucleus of the ion which it has an influence in the ionic bond. So an estimated value is taken in the case of ionic as a ionic radius. Let us compare metallic radius, covalent radius and ionic radius. Metallic radius, that is the half of the internuclear distance between the two adjacent metal atom. Covalent radius is half of the internuclear distance between the two atoms which is bonded by a covalent bond. And ionic radius is estimated between the distance between the two ions. So metallic radius found in metals, covalent radius in the covalent compound, ionic radius from ionic compound. So depending upon the metals, covalent compound, ionic compound, we'll find out these radius. So for simplicity, in this book, that is the textbook in the +1, we use the term atomic radius to refer both the covalent or metallic radius, depending on whether the element is non-metal or a metal. Atomic radius can be measured by X-ray or other spectroscopic methods. Atomic radii of few elements are listed in table 3.6 in your textbook. You can go through that values. When we compare that values, we find out that the values are in this way. So when you compare that values, you will find it out that the atomic radius is decreasing from left to right in a periodic table. That means when you compare the size of lithium with beryllium, beryllium is smaller in size, then boron is smaller than beryllium, then carbon is again smaller, nitrogen again smaller, oxygen again smaller, fluorine again smaller. So that means when we move from left to right in a periodic table, we can find out the size of atom is go on decreasing. And similarly, the size of an atom, when we move from top to bottom in a group, we find it out that the size is increasing. So why the size is increasing in the atoms in a group from top to bottom, and why it is decreasing towards left to right in the periodic table, that we need to discuss. That will be discussed in the next video. So when you find it out the periodic table, it is found that atomic radius is increasing in this way and it is decreasing in this direction. So that is all we have to discuss, which is called as periodic trends, that will be going to discuss in the next video. So this is all about the atomic radius, which we have discussed in this video. So students, have a nice day.